Welcome everyone. This is our Module 3 session on generating threat intelligence from an incident. This session uses data from Kill Chain 1, which will be made publicly available, and demonstrates how we can generate intelligence from an incident or intrusion and use that data internally. All right, advancing the slides. So we will touch base on our objective, and we're going to iterate. We're going to run through the CTI lifecycle here. We're going to start by touching on our stakeholders, requirements, goals, and objectives. Then we're going to get into the CTI analyst role during an incident and talk a little bit about processing intrusion data and information. And the bulk of the conversation really is going to be around analysis and production, the research and elements to include in a CTI report. Then we'll touch briefly on dissemination, how we're going to share this and who we're going to share this with. And finally, we'll wrap things up with feedback and evaluation, a critical step in the CTI lifecycle and CTI program in general. So we'll touch base on that here as well. So the objective is really straightforward. We're going to demonstrate the important role that CTI plays both during and after an incident. And moving right along into planning and direction, I'll go ahead and pass it over to Stephanie.
Great. So we're going to do an overview of the stakeholders in this scenario. So the stakeholders for this kill chain are our CISO, the CTO, the CIO, and executive board. We have people sitting in the SOC, so the defenders, forensics team, incident response, malware analysis, and threat hunting teams. We have SOC management and the IT team. And this phase of the CTI lifecycle is where our requirements are created. So we can see here in this diagram some of our goals and objectives. So we want to identify blind spots in our network, how we're getting attacked. So in our endpoints, network, platforms, we want to understand the adversary's capabilities. How are they attacking us? Why? What is their method of attacking us? And we want to also call out explicitly any new kind of defense mechanisms we want to create because of this CTI lifecycle we're going through. So those might be new detections we write, new threat hunts, new purple team test cases. So those might be explicit test cases you run with your purple team to check if a certain blind spot has been covered or not by your defenses. And while performing research isn't necessarily a stakeholder requirement, the CTI team should be digging into those IOCs to find new information that they can use to inform the various teams. So we can use different tools and analytical methods for this kind of research. And back over to Clay.
All right. So yeah, so touching on collection here. Right, so artifacts will be collected from different teams that are going to be involved during the course of an incident. This will be our IR team, our forensics team, and even our malware analysis team, who might get some artifacts from the forensics team. So all of these teams work together, and there might be, some people might be on multiple teams. So every organization, this will look different. Additional data and information will come from external sources through OSINT on existing data. So OSINT includes sources documented in our collections management framework or collection management framework that we've created. But we'll also include sources that are discovered through the process of pivoting, which we'll touch on in a little bit. Yeah, and pivoting on existing data plays a critical role during OSINT. When we're pivoting, when we're using open source intelligence, we might not know what data source we're going to run across that might be useful. For example, it could be an article or an in-depth malware analysis report that we find useful. So during OSINT, yes, we will rely on our platforms that we're aware of and that we've documented in the CMF. But at the same time, we're also going to be performing research that's going to lead us to new data sources that will pull those in as well. So just wanted to note on all of that. Processing. So this is the next phase in the CTF life cycle, and we'll be using intrusion data and information for this. Now, every organization will be different, and depending on the level of maturity the organization has, this could be very limited or quite verbose. TIPs are commonly used. So the TIP is a threat intelligence platform for processing, and OpenCTI is a free and open source platform. And here's just a quote pulled from their website. And yeah, it's a great way just to structure, store, organize, and visualize technical and non-technical information about threats. Automation of data from a TIP to a SIM is another commonly implemented process. And as we're working through these events or intrusions, the daily work we do, look for opportunities to develop this phase of the CTI lifecycle, and ideas will come at random times. You never know when an idea is going to strike or present themselves, but make note, document those, and that way you'll make improvements along the way. So now we'll get into analysis and production, and for that I'll kick it over to Lucid.
Alrighty. So analysis happens during an incident, and this can be to support other teams, and it produces CTI that will actually be in reporting. And the CTI team can really add value by analyzing OSINT, by pivoting through IOCs, like was already mentioned. And open source intelligence can be visualized and analyzed a lot of different tools, platforms, and models. And I'll have a demo here of a couple of those tools, VirusTotal and AnyRun, which provide sandboxing and visualization of IOCs. All right, I just want to highlight a couple of open source intelligence tools that we can use. Maybe if we have an active incident and we've been provided some IOCs, we can see what's publicly available about those IOCs and see if we can discover infrastructure or tactics or other things that could help us to help the other teams in incident response, threat hunting, to respond to an incident. So in this case, the situation is that the incident response team has provided us with a domain. A user has clicked an attachment in an email, and it really wasn't what they were expecting, and they reported it, and firewall logs showed that this domain, baseballcharlemagnelegardeur.com, was contacted. So we did a little bit of Googling first. Okay, this looks like might be a real, maybe French baseball team. So maybe this site isn't infrastructure that was set up by a threat actor, could have maybe been compromised. If this is really a malicious site, it's suspicious at this point. We can see an Alien Vault, which is another provider of open source intelligence, shows that this is probably a WordPress page. It's got this WP content in the links that we see here, the associated URLs. So maybe it's a compromised WordPress site. We'll see. Maybe we'll see nothing when we look at VirusTotal. Now, VirusTotal sandboxes URLs and files that people upload, and then comes up with a report essentially of all of the behavior from those executions. So if we look here, we can see that the domain itself is actually considered malicious by some security vendors, 6 out of the 94. As we go through the tabs, there's some more information about the domain, some relations. This is really the bread and butter here. VirusTotal, where it shows some of the behavior and other relationships between this domain and other files that contain this domain in their in the file itself, files that when run communicated with this domain. But really, the best visualization of all of this information is to use the VirusTotal graph. Now you can create this graph after setting up a free account, and we can look right away and see, okay, something must be wrong. There are, in fact, document files that communicate, doc and XLS, Excel spreadsheets that communicate with this suspicious domain. Now we already have more information than when we started with, but we can start to look over the graph, and we can see that these documents are considered malicious by security vendors, by different antivirus engines. And we can really start to pivot from here. We could find a document that's considered malicious and see what its other relationships are and expand those out. These aren't expanded right now. So for instance, if we expand domains, we will see that there's some other domains that get contacted when this document's opened. Some of them are related to Microsoft, so those aren't really suspicious. But there's other ones like this domain, Tango with Colette. And we can really just continue to expand, because if there may be other documents that also communicate with this domain, Tango with Colette. So we're going to find some additional documents. So this might give us, Tango with Colette. That's a pivot to infrastructure. And we pivoted from that infrastructure potentially to more tactics, to abilities that the actor has based on the results when these are executed in the sandbox. This is already a lot of information that we could pass back to the other teams, but we can really keep going. We can look around at the graph and see that there is also this PowerShell script. It's not quite obvious from looking at it that it is, other than the file name, that it's PowerShell script, but we could see that it is executed by several of these files that communicate with the domain, the suspicious domain that we've been given. So maybe our teams are going to start looking for PowerShell scripts in their tools, their on-premise tools. And another thing we can do is that we can take a document that has relations to this, what looks like a campaign, and we can run it through AnyRun. Now AnyRun is also a sandbox, but it will show and play back. It's interactive, first of all. When you run the file, you're able to interact with it in a virtual machine, in a sandbox. But then after the fact, it creates a report and a link back to that session that shows what happened in real time. So in this case, we can really just look back through all the public tasks to see if a file of that hash was run through AnyRun. Now we can see that there's a bunch of different runs. This is a historic campaign from a threat actor, Lazarus Group. And we can see that some of these may be more or less complete as far as whether the files actually reached out and downloaded a malicious payload. And that there could be all kinds of reasons for that. But this one here is probably the most complete run. And we can see on the right here the exact timings of the fact that Windows Microsoft Word ran, and that an exploit of some sort caused this PowerShell to execute. And we can see more information about this PowerShell itself and all the different events that happened as a result. We can get a PCAP that's actually a capture of all the network traffic that was generated from this session. We can see all the connections here and look through them and see if there's any other domains maybe that we that we missed when there's actually this towing operations. There's another domain here that we actually didn't I don't know that we necessarily saw that on our graph over here. So as you take bits and pieces that you get from one tool, you can put them into another, and you can find out more information that you can pass back as a list of IOCs. That could be very useful to threat hunting and everybody else that's responding to an incident. That is my demo of VirusTotal and AnyRun. So this graphic focuses on the production element of the phase. And this can be a template. It shows some of the things that go on a report. Doesn't limit you to just these items. The graphic section doesn't just show all. You're not limited to these graphics, but you could put things on there like a multi-go graph or just the diamond model. But this is a good visualization of all the things that would go on the report. And you're thinking about, with a complete report, does it tell, or if you're thinking about whether to put something on the report as you're completing it, you're trying to ask the question, does it help to tell the story? So one of the things from the previous slide, the diamond model for intrusion analysis, this can be used to both track both failed or successful intrusions. And it models the relationship between data points. And it helps with pivoting, testing theories about how things are connected or how an intrusion happened. So in this example, the antivirus on an endpoint within the organization detects a scheduled task that might be suspicious. That information is passed to a threat hunting team that discovers a maldoc, a malicious document, that communicates with infrastructure, which we see on the left of the diagram. We're able to resolve that IP to a domain name. And that domain name, we don't know who the adversary is. We're just going to use it to define our adversary. So because we had malwarelove.xyz, we're just going to call this cluster of activity part of malwarelove. And we can use this model to perform analysis periodically, whatever schedule makes sense for the organization. The other way to show the data in an intrusion is an intrusion summary. This is just a listing of all the different data points from the previous graph, same information. And intrusion summaries from inside an organization are really the best source of intelligence to show what's actually going on with that company, with thousands of attacks going on outside of the organization even in a single day. And the diamond model can help to visualize the data points from these summaries. And then you can start to see clusters of activity emerge from this process of going from a summary to a way of modeling or visualizing the data to starting to see patterns. The MITRE Attack Navigator, this is a web-based tool. It's free for annotating and exploring these matrices. You can visualize your defensive coverage. You can plan for red or blue team activities, purple team. This visual is a heat map of TTPs that were part of kill chain 1. This is an example. There's not everything that happened in kill chain 1 is on here. Not all of the little sub methods are on here. So you'll be able to there is a link at the end of the presentation where you can just search for this attack layer navigator and fill this out yourself. I will turn it over now back to Clay.
All right, excellent, thank you. So here is an example of a Maltego graph. Maltego is a link analysis tool that we can use to pivot and to find additional data points, information, and context. This example demonstrates how we pivot from an IP address to a file hash. So the file hash that I'm referring to here is the one that is tagged as sandstone malware. Just made that up. The malware has been attributed to a threat group. We see Stardust Kalima reference there, but it's also associated with another IP address, which has another website or URL associated with it. So all additional context. So now what? Well, the IP used in our intrusion can be associated to other pieces of malware, so we can see that. So this should be investigated for additional evidence. The malware we pivoted to in this example was not found in our environment. So it is possible that another adversary is using the same infrastructure, right? So further evidence is required in order to be able to identify that or apply some sort of level of confidence as well. So I actually added another piece of malware to demonstrate that there are two pieces of malware in this scenario now. So there can be different scenarios that come about, but just wanted to highlight this other possibility where another piece of malware was identified using that IP address, or that IP address was serving up multiple different pieces of malware there. And another one was identified, and it is attributed to a different threat actor. In this example, it's noted that the limestone malware has been attributed to Hidden Cobra. So for our example and demonstration purposes for kill chain 1, two different threat groups using two pieces of malware have been associated with that IP address, and each piece of malware is associated with a different threat group. Now, one thing that is interesting is that Hidden Cobra and Stardust Kalima are attributed to North Korea. So we could say with high confidence that our intrusion is associated with North Korea. Now, for Magnus Tempus, attribution is not one of our threat intelligence requirements. Maybe it is for your organization. I would argue for most organizations that attribution shouldn't matter. What matters is the intrusion, right? Who cares who did it? How would knowing the adversary change anything you do? Would it? I would argue that it wouldn't. Perhaps another discussion for another time, but since attribution is not in one of our threat intelligence requirements, it's an interesting observation that we can make, and an interesting observation that we can include, or an interesting assessment maybe that we can include in our CTI report. Yeah, it could be useful for other things as well, but Yeah, just wanted to really demonstrate that Maltego can be used for pivoting, finding additional information, and providing more context around an intrusion. And with that, I'll kick it over to Stephanie.
Great. So these last two sections will be about dissemination of the information and the feedback and evaluation. So dissemination here in this kill chain specifically, since all of our teams were involved in the incident, they're already aware of the outcomes. And aside from the report being generated and being delivered to our stakeholders, we don't have anyone else that we have to update about the incident, right? So there's no other dissemination required. In another scenario, if there was a team that wasn't involved and was not a stakeholder, you might want to think about how to distribute the information to them and what they need to know about the incident. So next we'll talk about, here are just an overview again of the stakeholders in this specific incident. So we had, or this specific kill chain, we had the executives, management, IT team, and then members of our SOC on the right. So next we'll talk about feedback and evaluation and a method for evaluating your CTI lifecycle. So here, during the planning and direction phase, you want to make sure you have defined, documented, and socialized processes for feedback. You don't want to be, you want everyone to know how to provide feedback, and you want a clearly defined process for this. You want it to be documented so everyone is aware. And you want really ongoing feedback. You want it to be readily available for people to give feedback to you. And once you receive this feedback, you want to evaluate your processes. So you want them to be complete, accurate, relevant, and timely. So we'll talk about these in a little bit more depth. So you want your CTI information intelligence provided to be complete. So does it have enough information to generate a proper response? So how comprehensive is the intelligence? Are all of the data attributes present? Is there vulnerability analysis? Does it correlate across an entire organization? And does it look at like non-cyber intelligence and other events for like a complete threat profile? So this comes back to like your intelligence requirements at the very beginning. Were you able to capture all of these, and did you deliver? The next part is, was it accurate? So were there errors in your generated intelligence? You know, what data sources did you use? Were they accurate? Was this the most up-to-date information, or were there information changes along the way? And is it time-bound? Is there like an expiration for this intelligence? Sometimes if you provide information about specific IOCs, those might change very quickly. So it's important to note if it's time-bound and how long this will be accurate for. Okay, so now we'll talk about, is it relevant and is it timely? So your intelligence has to address the relevant threats inside your organization and be delivered in a way that allows for effective action, right? So does it map back to your original intelligence requirements? How do the stakeholders submit requirements and provide feedback for more relevant intelligence? And is it timely? It has to be produced and delivered quickly, so it can be used fast enough to make a difference. So how is it delivered to ensure quick consumption? Is it delivered by email, etc.? How long between the discovery of a threat and notifying the stakeholders? And is this intelligence released to the stakeholders as you go along and you learn more, or is it at the very end? So that's it for feedback and evaluation, and I'll pass it back to Clay.
All right, thank you, Stephanie. Yep, so here's some resources that were touched upon in the presentation. thank you. Thanks for watching. We join the conversation on Discord here. This is our Discord. There's also the DEF CON Discord that folks should be in. We'll be monitoring those channels as well. So please engage there. And wanted to call out that we did create a module 1 session, and that was released prior to DEF CON. So if you're unsure about any of the content in this module 3, be sure to refer back to that module 1 session that is available and up on YouTube. So thanks again, everyone, and look forward to engaging in the conversation, and see you in future modules. Thank you.